Good day, Dr. Ryan. I am Vincent Bayona from BSCPE 41 and I'm going to discuss about the SAP 1 architecture. SAP 1. SAP 1 or Simple as Possible 1 Computer Architecture. SAP 1 is a simple and educational model of a microprocessor designed by Albert Pau Malvino. It was introduced in his book Digital Computer Electronics. The SAP 1 architecture serves as a foundational example for understanding basic computer architecture principles. Now, let's go to the circuit components of the SAP 1. First is the program counter. Program counter is a register used to keep track of the memory address of the next instruction to be fetched and executed. When the computer is powered on or when the new program is started, the program counter is initialized with the memory address of the first instruction in the program. The program counter points to the memory address of the next instruction to be executed. The instruction is fetched from the memory address and loaded into the instruction register. After the instruction is fetched, the program counter is incremented by the size of the instruction. The size of the instruction is determined by architecture of the computer, like 1 byte, 2 bytes, etc. The program counter is a fundamental concept in computer architecture and is essential for the control flow of the program. It ensures the instructions are executed in the correct order and sequence. Branch instructions such as jumps or conditional branches can modify the program counter to redirect the flow of the program to a direct memory address. The instruction register. The instruction register is a register that temporarily holds the current instruction fetched from memory during the instruction fetch phase of the machine cycle. The instruction register serves as a temporary storage location for the current instruction being processed by the CPU. It plays a crucial role in the instruction cycle of the CPU, facilitating the sequential execution of the machine instructions. The contents of the instruction register determine the specific operations that the CPU needs to perform at a given moment in the program's execution. Accumulator. The accumulator is a special-purpose register within the central processing unit of a computer. It plays a key role in arithmetic and logical operations. The accumulator is used to store intermediate results of computations and is a fundamental part of the ALU within the CPU. Memory Address Register or MAR. The Memory Address Register is a register within the central processing unit that holds the address of the memory location to be accessed or modified. Input Component. The input component is a more general term and often refers to the devices or mechanisms that allow the computer to receive external data. Input devices can include keyboards, mice, sensors, or any other devices that provide data to the computer. In the addition mode, the adder subtractor adds two binary numbers. Each bit of the binary numbers is added along with the carry from a previous lower order bit. While in the subtraction mode, the adder subtractor can perform binary subtraction. Subtraction is usually achieved by adding the 2's complement of the number to be subtracted. 16 by 8 RAM. The 16 by 8 RAM can store 65,536 different 8-bit values. It is important to note that the term 16 by 8 primarily refers to the organization of the memory, where 16 address lines are used to access 8 bits of data at each address. B register. The B register could be one of these general-purpose registers and it will be used for various purposes such as storing data temporarily, during arithmetic or logic operations, during an addition or subtraction operation. Data from the memory is loaded into the B register and the result is stored in the accumulator. Sequencer. A sequencer is a component that plays a crucial role in controlling the flow of operations within the central processing unit. The sequencer, also known as control unit or instruction sequencer, is responsible for orchestrating the execution of instructions in the correct sequence. The sequencer generates control signals that coordinates the activities of other components within the CPU, such as register, the arithmetic logic unit, and the memory. Binary display. A binary display typically refers to a visual representation of information using the binary number system, which is based on the digits 0 and 1. In electronic systems and computers, binary is a fundamental language used to represent data and instructions through combinations of these two digits. Binary clocks are timekeeping devices that display the current time in a binary format. Each digit of the time, such as hours, minutes, and seconds, is represented using binary digits, often with LEDs or other indicators. For the last component, output register, an output register in the context of computer architecture typically refers to a register used to temporarily store the result or output of a computation or operation before it is transferred to another part of the system. Registers are small, high-speed storage locations within the central processing unit that facilitates quick access to data during processing. Next part is the SAP1 instruction set. The instruction set of a computer are the basic instructions it can perform. The instruction set of the SAP1 is described in a table. First, for the operation, load, it loads data from memory to the accumulator. Next operation is add. It adds data from memory to value in the accumulator. Next is subtraction. It subtracts data from memory from values in the accumulator. Next is output operation. It loads data from accumulator to the output register. Next operation is halt. It stops processing. In designing process, to build the SAP1 computer, circuit diagrams were designed for each component. These components were integrated into one system using buses. Each circuit diagram was designed and simulated with CircuitVerse, a tool for designing and simulating logic circuits.